what's up? This is Justin, the Lester Dog Tutorials, and this episode of the Retro FPS tutorial series for Unreal, we will be adding in an enemy. And we won't be doing the logic in this one, we'll just bring the enemy in and make sure that he's affected by the ability system. And then also, we want to make sure that his sprite is always facing the player. So the first thing I think we want to do is we'll create a folder in the textures folder that we'll call enemies. And then inside this, we will just import the sprite sheet for the enemy, and a link should be in the description of the enemy that we'll be using. So once it is imported, you'll notice that the background is blue. So you'll have to open up your favorite image editor and just remove that background so that it is transparent. And you'll probably have to change the mode from index to RGB. And if you save over it and import the changes, we'll be good to go. So with it imported and the background transparent, we're going to right-click, go to Sprite Actions, apply the Paper 2D settings, and then right-click again, go to Sprite Actions, and extract sprites. We will just leave this on auto because I believe that's going to work. If not, we can deal with it later. And then after it's imported, you can just scroll down and you'll start seeing these weird blood specks. So delete these, but leave all of the images that have the actual enemy in there. So now we kind of have to do a lot of repetitive work to create the flipbooks for each direction that this character is walking, plus their firing of the weapon and their death animation. So also I think they're getting damaged here too. So let's do some quick stuff here. First, we'll target the walking. If we select settings and go to list, it's going to be easier to grab some stuff. So let's grab, for the front walking animation, we'll grab 0, 8. And you can see the next one is 16. And the next one is 24. So 0, 8, 16, 24. And then you can right click that and create a flipbook. We'll just call that FB underscore outleader underscore front. And then I'm going to kind of speed through this, but you just increment it by 1. So if the first one was 0, 8, 16, 24, the next one will be 1, 9, 17, and 25. And that turns front left a little bit. So then I'll do all those. It'll be front left. And then the next one will be 2, 10, 18, and 26. We're just increasing the number by 1 each time. And that one will be facing left, and then it'll be back left, and then back right, and then front right, and then we'll be done with walking. All right, with those completed, just the walking animations, I'm going to grab all of these, which should be a total of, I think, what is that, 8? Yeah, it should be 8 total directions. And I'll move those over to the flipbooks. So 1, 2, 3, 4, 5, 6, 7. Okay, we're missing one. Oh, right here. All right. So now I have back, back left, back right, front, front left, front right, and then left and right. So far, most of these animations look good. The only ones that don't look that good are left and right. And if you open these up, you can see one of them is jumping around. So if we turn this frames per second down to 2, we can see that the last frame here is not in line with the other ones. So that's number 30. So also if we look at the left one, the last one is 26. So 26 and 30 need to be adjusted. So if we go to textures where the enemies are, then we can go to 26 and 30. So if we open number 30, we can change that pivot mode to be custom. And then we can change the custom pivot point on X to something like 684. And that will move him back more in line. Next, on 26, we also can do a custom. And for X, we'll go down a bit. So we'll do maybe 286. Let's try 280. And now if we look at this, if we switch it to 8 frames per second, it looks much better when he's walking to the right. And then for the left, that looks good too. So now we can just go through each of these flipbooks, and we'll switch the frames per second to be 8. And you can actually select all of them, right click, and we'll do asset actions and bulk edit via property matrix, which then you can just change frames per second to be 8 and then save all. So now we have these animations ready to go. Why don't we create a character using these so we can figure out how to make the sprite always face the player, but then also be facing the correct direction depending on where you're looking at this enemy. Head over to the blueprints folder, and right in here we'll just make a folder for the enemies that we'll call enemies. And in here we'll just make a blueprint that's based off our retro FPS character C++ file. And we'll call this BP underscore enemy. And all enemies will be based off of this, so we'll just do general functions and things inside this. So go ahead and open that up. And the first thing we'll do is we will add a flipbook so that we can see the actual enemy. And we'll just call this character. Or actually, let's call it enemy. So the first thing we'll do is just change the flipbook to be something temporary so we can kind of see the character moving. So let's go ahead and switch the viewing angle to be right and make sure that it's set to lit and not wireframe. And then with the actual flipbook selected, let's change the scale to 1.5 on everything. And then we can just move the character down so he's more in the middle of the capsule. And then, speaking of the capsule, we can change its height so it matches the character a little better. And I think something like 64 might be good. And I've moved the enemy down -60. So with that done, I think we have the beginning of our character, or of our enemy character. And so we can try dragging this into the scene and kind of see how it looks. And I think that might be fine in terms of its size. Actually, you know what? I think it should be a little larger. So let's go ahead and change its scale to be 2. And just to really quick see how that looks, it might actually be too big. You know what? I think that's good. It's kind of intimidating. So his scale is set to 2, and then we'll just switch back to the right perspective so that we can change this capsule component to encompass the entire character. So I'm going to switch it to 90 as the half height, and then I'll move that enemy down so it's in the middle of that capsule. Cool. And then back to testing, it is going to still be on the ground, which is what we're looking for. Cool. And of course, if you shoot it, nothing's going to happen, so don't try. Next, we're going to go back into the enemy, and we're going to switch over to the event graph, because what we need to do is figure out how the sprite will always face the player. And we've done this already with the weapon, but this one's going to be a little more complicated, because when the character is walking around, the sprite still needs to face the player. However, depending on the direction the enemy is moving, we need to see a certain angle of the enemy as they move away or towards you or whatever, but still facing the player at all times. So let's figure that out. The first thing I want to do is create a macro, and I'm going to call this Sprite Face Player. And in here, it's just going to be kind of what we did before, so I'm just going to add the in and out exec pins real quick. So the first thing I'm going to do is get the player camera manager. And then from that, I'm going to get the camera location. And then what I want to do is grab this enemy flipbook, because we need to get its world location. And then we need to drag out from the return value, and we're going to find the look rotation, and the target is going to be the camera. And then I'm going to split this return value where it splits the struct into x, y, and z. And then from z, I'm going to subtract. And I'm subtracting 90, so it faces the player. And then all I'm going to do is from the enemy Flipbook, I'm going to drag out and say set world rotation. And then all we're setting the rotation to is, well, we're splitting the struct because we need just the z. So the z is the only thing that's going to be rotating. And then you hook up to the out, and that should be all we need. So now in the event graph, you need to put that right after tick. And then compile and save, and we can actually play this, and you'll see the sprite is facing the player. Back in the enemy blueprint, I went ahead and I added Footbook variables for each direction that the enemy can face. So I made one for front, front left, left, back, back right, right, and front right. And then I put them in a category called Flipbooks, and I made sure to make each of these public variables so that they can be changed in any sort of blueprint that will inherit from this. Now I want to make another macro that I'm going to call getEnemyAngle. And this will just run all of the necessary math that will determine which Footbook we want to play based on the player's location. So make sure that you add the in and out exec pins. And then we'll do some math over here. First thing we want to do is get the actor forward vector. And then we'll split that return value because we want to make a vector using x and y. Under this, we'll get the player pawn. And from that, we'll get the actor location. So we're getting the location of the player. We're splitting this return value, and we're doing the same thing. We're making a vector using x and y. We're not wanting z in any of these. Next, we'll get the actor location. So this is the location of the enemy. And we'll split the struct pin, and again, make a vector using x and y. And lastly, down here, we're going to get actor right vector and create yet another vector. So now that we have all these, we can do some math to these to understand kind of where the player is and what Footbook the enemy needs. So the first thing we want to do is take these middle two sections, and we're going to be subtracting the enemy's location from the player's location. So we'll just pull out from the return value up here and do a subtract operator. And we're just subtracting this one below it. Then we will normalize the return vector. Next, we want to up here at the forward vector, we'll drag out and we'll look for the dot product, which essentially converts both of these into a float, and we're just kind of seeing what they have in common. So based on the enemy's forward vector, we're getting the player's location and the enemy's location, and we're normalizing that, and then we're saying where is it in relation to which direction the enemy is facing. And from this, we're looking for a node called a cosine degrees. And then this number here we'll want to keep track of because that's going to be the enemy's angle. So we'll just create a new variable called enemy angle and make sure that it is a float. And we'll set that to be equal to this. Now, on the bottom here, we need to also get another dot product, but this time we're using the enemy's right vector. And then we're checking if this is less than 0. Now what we're doing basically here is we're saying the right side of the enemy, is it less than 0 or greater than 0? Because if it's less than 0, then we're on the left side of the enemy. If it's greater than 0, we're on the right side of the enemy. And this is also going to help us determine which side of the flipbook we're using. So whether or not we're using back left, or back right, or left, or right, etc. And so we'll just branch out from this right up here to determine this right after we get the enemy's angle. And then we can keep track of this by creating a Boolean called left side visible. And then we can set this based on the return of this branch. And so if this is true, left side is visible, and if it's not true, it is not visible. And then we leave this function. So now we have what we need to determine which side we're looking at and whatever angle the enemy is in relation to the player. So I'll compile and save that, and I'll tack that on the end here, right after Sprite Face player. The next thing I'm going to do is create another macro, and I'll call this set facing. And in this macro, I'm going to add those in and out exact pins real quick. And then what I'll be doing is I'll add 2 other inputs, and both of these will actually be flipbooks. And the top one will be called left, and the bottom one will be called right. And I just want to check right when I come in here whether or not the left side is visible. And then I will set the flipbook of the enemy to whatever I'm passing in depending on the direction. So if it's true, then left is the direction that we are. And if it's false, then we're setting it to the right. So with that done, now we can add another macro that we'll call calculate flipbook. And in here, we'll add those in and out pins again. So in this macro, we're going to do some calculations, and it will be a series of branches. So the thing that we're going to be looking at is what is the enemy angle at? So the first thing we want to check is if it's less than a certain number, and we'll say that this number is 22.5. So if the enemy angle is less than 22.5, we can say that the facing of the enemy is set to front. So instead of saying that that's going to be front, we can just drag in this and say, here you go. Now we know that the character's set to front, and that's either if it's left or right. It does not matter. If it's false, we'll go to another branch, testing again if this is less than a certain number, and the number we'll choose for this one is 67.5. So branch from that. So if this is false, it's greater than 22.5. We'll see if it's also less than 67.5. And then if it is, we will set the facing again, but this time the facing is going to be either front left or front right. So the front right goes into the right, front left goes into the left. All right, so we got the front and the front side figured out. And so now we'll just need to do this again like this, and probably again here. So we'll just plug this in like this. And then for this next one here, instead of 67.5, we'll do 112.5. And then instead of front left and front right, we're just doing left and right. And then down here, instead of 67.5, we're doing 157.5. And instead of front left and front right, we're doing back left and back right. So now that we have all of them figured out except back, that's what false will be. Down here, this false. So then that will be both. Both will be back because it doesn't matter what side you're on. And so this is really all we need to do in order to determine which direction the enemy will face. So if we plug this in to say calculate the flipbook, we can see if this works. So now if we wanted to test, there isn't going to be anything working because we don't have the actual flipbooks set up. So let's go ahead and create our child blueprint class, and we'll just call this BP underscore pistol enemy. So this is going to be the guy that has a pistol that we will program in later. But for the actual pistol enemy, we'll just set these. We'll delete this enemy here, and we can drag in our new pistol enemy. So now that that character is in there, I can select these different flipbooks for this pistol enemy. And so front and then front left. And then we got left here. Then we got back left. Back right. Right. Front right. And I think that's it. So now that that's set up, let's go ahead and test it out and see if it works. So now the character, you can see he's facing to the right, and I keep moving, and he's continuing to face that direction. So it would appear that this is working indeed, which is a pretty cool effect and fairly simple to set up. Awesome. Now that that is done, we can actually figure out a few more tiny details in terms of how to animate him, and then we can figure out the AI that will go on this character, and actually also implement a damage and attack system. So before moving on, why don't we just go to the flipbooks of the enemy, and we will do the asset actions and bulk edit via property matrix. And we're just going to select the sprite material that we have. And again, if you see all of these different materials, that's because the editor or engine content is on. So if you turn that off, you'll just see your personal material. So we'll just choose the sprite material and save all. And just to see and make sure, yes, that is working. He is actually lit by lights now. If you recall, in our last video, we made this attribute set, and we had a couple of attributes for each of our characters in our game, one for health and one for armor. And then also, if you recall, we created this default ability or default attribute effect variable, both of these. And the default attribute effect was the thing that we were using as a way to give a character an attribute at the beginning of the game. So why don't we define that for our player and for our enemy to decide how much armor or health each of them has. So back in the editor, just in the blueprints folder, I'm going to create a new blueprint class of the type gameplay effect. And I will just call this GE underscore player starting stats. And in here, once you open it, there's really not much we're going to do in here, but over here in the duration policy, or the gameplay effect area, we'll keep it at instant, because right when we start the game, we want to give the player health or armor. And then for the modifiers, we'll just add 2 elements. And the first one, when you drop it down, you'll see there's an attribute drop down, and you can actually select the health and armor from the C++ file we made. So I'll just do one for health, and instead of add, I'll do override. And then in the magnitude section, I'm just going to change this to be 100, so the player will start with 100 health. Then in the other one, down here, I'm going to choose armor and override, but I'm going to leave this at 0, just so that the player starts with 0 armor. And then I'll compile and save that, and then we might as well just duplicate this. And instead of player starting stats, I'm going to name it pistol enemy starting stats. And in here, I'll just change the health from 100 to something smaller like 40. And then when those are done, you can just compile and save. And I'm just going to move the pistol enemy starting stats into the enemies folder. And then I'll move the player starting stats into the player folder. And then all we need to do now is open the player. And then over in the class defaults on the right side, we'll see that there is the default attribute effect. And I'm going to choose player starting stats. And then, after we compile and save, I'll head over to where the enemy is, the pistol enemy, and again, do the same thing and choose default attribute effect. We'll choose the pistol enemy starting stats. And now, each of these characters will start with the health and 0 armor. But if you play, you'll see that there is really no indication that the characters have the health that we've given them, but it is actually a part of each character. So let's see if we can find out how we can show that on the screen. So right now, both of our player and enemy characters, they both derive from our C++ Retro FPS character class. But I want to make a blueprint class that they both derive from as a way of adding blueprints and things to all characters without messing with C++. So let's create a new blueprint class based off of our Retro FPS character. And we will just call this BP Retro Character. And then, since we made that, we can actually go to the player and say that it derives from the BP Retro Character, and that won't really change anything. And then the enemy class will also derive from the same Retro Character, BP Retro Character. All right, so now that they both derive from that, we can open that character. And what we'll do is just we'll go to the event graph, and on begin play, we're just going to take this ability system component, and we'll drag out from it, and we'll do a get float attribute from ability system component. And if we select the attribute drop down and we select the health, then it will return the health of the class. So in order to show that on the screen, we'll actually want to print string. However, first we want to delay just a frame, so we can do a duration of 0, so that it will have time to initialize first. And then from it, we can print string, but let's make it so that we know whose health we're talking about. So we'll want to do an append, a string append node. We'll make sure that there's 3 entries. And what we'll want to do first is we'll right click and we'll get the display name. Right? So we're getting the display name, and then for the object, we'll choose self. And that will be the first entry there. And then the second entry will do '(S), and we'll say current health is at, and then the return value of this float attribute will go into the last one. And then that will be the string that we print. So let's go ahead and see if that works. Okay, it worked, but it's not staying up there for very long, so let's just say the duration for now will be 60 seconds. All right, so it says at the top there, pistol enemy's current health is at 40, and the FPS player's current health is at 100. So we have the actual health being set correctly at the beginning of the game. Now, let's figure out how we can remove that health using our ability. So now let's create the actual effect that will be applied to the enemy when we shoot them. So in the abilities folder within the blueprints, we're going to create a new blueprint class. We're going to look for gameplay effect again. And we'll create one of those, and we'll call it GE underscore pistol damage. And you know what, we could just say player pistol damage, because the amount of damage that this does will change if it's the enemy using it. So in the player pistol damage, we're just going to make it an instant, and then we'll add a modifier. And for the attribute that we're going to modify, we'll say health, and then we will say that the magnitude will just be -20. So 2 shots should kill our enemy. And then if we look in the player pistol ability, in the class defaults, over here on the side, we have the weapon effect, and we could just say that it is the player pistol damage will be the effect that is used when this is fired. Also, while we're in here, we can go to the apply effect function, and we can actually clean this up. We don't actually need these nodes here. We don't need to cast to a retro FPS character, and we don't need to get the instigator. These things will work just fine without casting to anything. So the target actor can be the target, and the attacking actor will just be this actor here. And be sure that you're connecting the target actor to this ability target data from actor node. So in order to actually test out that it is working so that we can see when the enemy is hit, we're going to create something called a gameplay queue, which also can be used for switching the enemy's flipbook to be the damaged animation and any sort of like blood effects or whatever that we want to occur when we actually hit the enemy. So let's make one. However, we can't create it by right-clicking and selecting a new class. We'll actually need to go up to Tools up here, and you'll see this Gameplay Queue Editor in the dropdown. If you open that up, you can see kind of a screen that will look like this. And so what we want to do is add a new Gameplay Queue tag. You'll see in the name section it says Gameplay Queue dot. So why don't we just say pistol or player pistol damage. We'll just do that. Player pistol damage. And then we will add the new tag. And then down here in the handlers, we can click Add New. And we can either create a gameplay queue that is a non-instantiated U object, or an actual actor that handles the gameplay queue. We're just going to use this top one here. This is a non-instantiated U object. So click that. And then it's going to create a new gameplay queue. And it's going to have the GC at the beginning and an underscore. And everything looks like how I would name it. So we'll just hit enter, and now it has been created. And we can also just kind of move this to the folder that we need, where I'm just going to move it into blueprints. And I'm going to create a new folder in here called gameplay queues. And I'll drag that gameplay queue into there. So now really there's only a couple of things left to do. And what we want to do is link up the player pistol damage gameplay effect with the queue that we just made. So if you look in the class defaults on the right side, in the section called display, you'll see the gameplay queues section with 0 array elements. So if we just add an element and we say We can skip actually all of this stuff up here. All we need to do is add the gameplay cue, player pistol damage, and that's it. It's just the tag that it's going to look for. And so if you were to open the gameplay cue, then you'll see that the gameplay cue tag up here is the same as the tag in the effect. And what we'll want to do in here is override a function called onExecute. And you can remove the parent onExecute node because all we need to do is return true by ticking the box in the return node. The first thing we'll want to do in this is drag out from my target and cast to the BP retro character. And then we'll need some sort of function on the retro character that can take in the parameters here, the gameplay cue parameters, and also perform any sort of function that we want, like reacting to a bullet or some sort of like blood effects or anything like that. So let's head over to the retro character. And we're just going to add a custom event here. And we'll call it take damage. And then for the input, we'll add an input. And we'll look for gameplay cue parameters. And we can just call that cue data. Next, we'll want to break the cue data. And then we'll get some information here. And the one we're wanting is the location. And we're just going to drag out from that and report damage event. And then we can just hook that up like this. And then for the instigator, we can drag that up into the instigator. And for the damaged actor, we can just say it's self. And with that out of the way, we can then go ahead and report what kind of health we're at after being shot. So if we just copy and paste this top section, then what it's going to do is get the float from the ability system of the specific attribute of health, and then it's just going to say this object's current health is at whatever the return value is, and this is a good way to just see if it is indeed removing the health of the actor that we shoot. So if we compile and save and head back over to the gameplay cue, we can take damage right after we cast and make sure that we pass in the parameters and then hook up the return node. Now before we test this out, we need to do one more thing. In the actual enemy blueprint, select the capsule component, and then over on the collision presets, we want to change it from pawn to block all. This is because the visibility for pawn is usually checked on ignore, and we want to make sure that it's blocking because when we shoot the enemy, we want the line trace to register. Now let's test it out. All right, so it gives you the initial starting health of each of the characters. I have the gun, and if I shoot this character, it should remove 20 from his health. And now it just said the pistol enemy's current health is at 20, and I do it again, and it is now at 0. And so it appears to be working. We are actually affecting the health of the enemy, and that is awesome. That's going to do it for this video. I'm going to keep it a little bit shorter because there is still a lot to do, so we can kind of dive more into AI and the enemy firing and reacting and getting hit, things like that in the next video. So if you like the video, please hit like, please subscribe, and I'll see you in the next one.